This is our second video in the Second in the Life of a Circuit series, where we'll be modelling what's going on in a circuit using the Lollie circuit idea. So that's using skittles here to represent the energy that's stored in the battery, and that energy will be taken by the charges moving through the wires. So in this case the free electrons moving through the wires will carry that energy around the circuit, and the energy will be transferred to the loads in the circuit. So in this case our loads in the circuit are two lamps, so each with a resistance of 2 ohms. So when we have two 2 ohm components in parallel, the total resistance is going to be 1 ohm. We can use that data together with the fact that we know that the battery is 4 volts to work out the current flowing in the circuit. So using Ohm's law, rearranging to find current I, it's voltage over resistance, so 4 volts divided by that 1 ohm gives us a total current in the circuit of 4 amps. So that means 4 amps will flow from the battery around the circuit. That 4 amps, we can also think of that in terms of the coulombs per second. So 4 amps means 4 coulombs of charge is flowing around the circuit every second, flowing from the battery and going around the circuit. We'll represent that using some cups as the coulombs of charge. So we would have a total of 4 cups collecting energy from the battery and flowing around the circuit in 1 second. So each cup, as it goes to the battery, would have some energy transferred to it. So energy is being transferred to the charges. That 4 volts there means 4 joules per coulomb. So 4 joules of energy is transferred to every coulomb of charge. We're using 4 skittles per cup to represent that. So in total 4 amps, so 4 coulombs, 4 lots. It will be collecting energy from the battery to then transfer to the rest of the circuit. All of these charges, all of these coulombs of charge, they're all going to flow past this ammeter here. There's no other pathway for them to go past. So that means that 4 amps will be measured by this ammeter. So that 4 amps is the same here, 4 coulombs per second flowing past that ammeter. However, when we get to this point in the circuit here, where we've got a junction, there are 2 pathways that the current could flow along. Because both of our branches in our parallel circuit have the same resistance, the current, the charges, will divide equally between each branch. So 2 of the coulombs of charge would flow down that branch, and the other 2 would flow down this branch. So if we look at the ammeters that they're going past, this ammeter here, 2 coulombs in that 1 second will go past that ammeter, so that ammeter is measuring 2 amps. And then if we look at the other ammeter, the same here, so 2 coulombs per second, or 2 amps is measured by that ammeter too. Now each of the coulombs of charge, all of those electrons that are flowing around, they will transfer their energy to the components that they go past. So in this case the components are the lamps. Put some cups here so that the energy that gets transferred, we've got somewhere to put that. Each of these coulombs of charge, each of these cups, is only going to pass 1 lamp on its way around the circuit, and all of its energy will be transferred to that lamp. Okay. So that by the time those cups go around and back to the battery, they've transferred all of their energy to the circuit. If we check the voltmeter reading then, each cup transferred 4 skittles. So that's 4 skittles representing joules. The cups are our coulombs of charge. So 4 joules per coulomb being transferred to that lamp. That's 4 volts. We look at the other lamp as well, the same is happening there. All 4 the skittles, or 4 joules of energy, are transferred to that lamp. So again, this lamp would also measure 4 volts. When we check the pathway that the cups or the coulombs of charge have followed back to the battery, we see that all 4 cups have gone past that ammeter in 1 second. So again, this ammeter reads 4 amps. The cups would then go on to pick up more energy from the battery, and again the process would repeat in the next second as well. One other thing that we can check is looking into our cups. We can see how many joules of energy were transferred to our lamps in that 1 second. So checking in this cup, there were 2 lots of 4, so that's 8 in total, 8 skittles in there, representing 8 joules. This is all happening in a second in the life of a circuit. So 8 joules per second, that's 8 watts, that's our power. So power is telling us the rate of energy transfer to that component, so an 8 watt lamp